All right, here we go. Now, what I want to do, instead of working backwards today, all right, we're just going to go back to where we left off, which was, is that right? I mean, the last note I have is 26, right? Now, I asked you guys to try them last night, and some of you did a great job, it looks like. Some of you said that I had too much trouble with it. You kind of stopped at some point, which I understand that also. All right, so here we go. All right, which is kind of funny. You can see how old my worksheet is here, guys. Because some of my kids didn't know what a CD was, CD case. Anybody remember what a CD case is? All right, everybody knows what a CD case is? Okay, I don't feel that old then. Yeah, that's right, except they were actually things that music were on. Right. Or yes, DVD. Yeah, the circle thing. That's right. And the case that you put those little circle things in. All right, there we go. Yes, the big square. Okay, so first and foremost here, I just want to see if anybody's thinking through this. All right? And I want someone, Jack, what did you get for number 26? So far I've got a 40. Anybody else? What do you think? 5 and 5/8. I'm not sure what that means, but we'll write it. What is this? 5. And again, what do we got? 19, 40, 27, 53, good. 40, good. 40, now again, it's okay. It's all right. That's what I'm saying. I'm giving everybody a chance. And you can put on there question mark. That's perfectly fine. Now, my job now, Jack, my job now is to try to see or show you how you can see the answer. All right, that's what I'm shooting for. All right, I want you to be able to visualize it just like I'm visualizing. Because again, this problem is kind of easy actually. All right, but there's a lot to it. All right, so the first thing we're doing is we're kind of like visualize my shelf over there with books on it. All right, but all the books are exactly the same. That's what we're trying to figure out. Then how many books could I fit on a shelf? All right, so let's look right here. All right, so first and foremost, what I'm going to do is I'm going to try to make a shelf. All right, and here is going to be my shelf. All right, now on my shelf here, all right, I'm putting certain things on my shelf. And my shelf is exactly how wide? How wide is my shelf? Someone tell me. 20 inches, right? So I would like for you to put 20 inches up here. Now, this is really old. I'm not sure if anybody knows what a cassette is. Somebody know what?
Yes.
You know what a cassette is, too? All right, that's pretty cool. All right, you know what a cassette tape is. All right, so cassette tapes was before CDs. All right, that's how you listen to music, was on a cassette tape. Right? Yes. All right, so now what I want to do now is I'm going to draw how many cassettes? 8, and I'm going to put them on my shelf. So here's what I'm going to do now. Here's what I want you to think about. I'm going to draw one cassette tape here. That's one. All right, now I'm going to draw another one. All right, and then I'm going to draw another one. And how many am I drawing? All right, I'm going to draw 8 of them here. Come on, quiet. You're still quiet. All right, so now I have drawn 8 cassette tapes, and I've stacked them right next to each other up against the wall. All right, now I'm not expecting you to draw that. All right, but I'm saying that's a visual. All right, now if I blow this up here, this cassette is how wide? How wide is this right here? 5/8 of an inch. Thank you. It's 5/8 of an inch. So now my question to you is, how much is that length from there to there? What do I do? 5/8 times 8, guys. Does that make sense? Now again, I don't want you just typing in 5/8 times 8 without saying, wow, okay, that makes kind of sense, right? So 5/8 times 8 means there is what? How many inches have I used so far? How many? 5 inches. Don't worry about it. Don't worry about it. So I've used 5 inches. That's what I'm saying. The part about drawing it makes it all crystal clear. Don't be lazy. And I don't need any other. Just listen. Let me do the talking. All right? Now, how many inches do I have left for CDs? I have 15 inches left. So now I'm saying from here to here is 15 inches. Now the question is, how could I figure out how many CDs I can fit in here? What do I have to do? 15 divided by 3/8. That's exactly correct. Now, again, how did I know it was 15 divided by 3/8? Because what am I doing to the 15 inches, boys? I mean it. You got to be up here, not whispering, telling me something. All right? I'm trying to make it clear for everybody. So how did I know it was division? What am I actually doing? That's right. And what am I doing to this 15 inches? What am I doing to the 15 inches? I'm dividing it up. That's how you're supposed to know that, Jack. All right? But you're still interrupting me. What? That's correct. No, 5/8 times 8. It was. That's right. Exactly. This is what the picture is for. Look right here. This distance from here to here is 5/8 of an inch. There you go. That's exact. Now we're on board. Okay? And now, someone tell me, if I took the 15 divided by 3/8, Jack, again, what was that? It was 40. That is correct. You could fit 40 CDs on that case.
I didn't read it all the way, so I thought it was 20 inches.
Yes, I'm okay with that. Now, that's why I'm saying it's important. Read carefully. All right, read carefully. You okay? Any questions? All right, let's try the next one now. Tell me, read it. So what am I doing? What's that? All right, so now I'm going to draw something. You tell me. Hold up. Look up.
What is that?
I'm not saying whether it's correct or not. We're drawing the picture so we can see. That's what we're doing. All right, so you can see clearly what to do. All right, so from here to here represents what? What does it represent? It represents 12 hours. That is correct. And now what? Every what? 3/4 of an hour, what's happening? Alarm goes off. So here, alarm goes off. Here, the alarm goes off. Here, the alarm goes off. Here, the alarm goes off. Emiliana, what am I doing to the 12 hours? No, you have in your head what to do. I'm asking you to look at my figure, and what am I doing to the 12 hours? That. And what's splitting mean? What operation? Add, subtract, multiply, or divide. So let's look at this. So this is 3/4 of an hour. This is 3/4 of an hour. This is 3/4. This is 3/4. That's 3/4. All right? Well, yeah, I could eventually add up until I get to how many? 12. So if you wanted to, you could take your calculator and go 3/4 plus 3/4 plus 3/4 and do that until you get to what? 12. Or what I'm trying to show you is what am I actually doing to the time? There you go. We're trying to be quiet, all right, so I can help other people. That's possible. What I'm trying to show you is I'm taking the 12 hours and I'm sectioning it off into what? Into what? Say, well, we could say minutes, but I'm okay with hours. But I'm saying this whole length right here. I know it's hard for you to think about when I'm saying length and then telling you it's time. But you can measure time kind of like a length, right? So there's 12 hours. So what am I doing? So, okay, let's do this. So at what time would it go off? What's the next time? Oh, let me think about it like this though. Because you said multiply. Do me a favor, just multiply 3/4 times 12. Tell me what you got. 9 hours. Or 9. You're thinking it'll ring 9 times, right? Now, here's what I want to tell you now, because I think I can help you with this now. If it rang every hour, how many times would it ring? 12. Exactly. So it's ringing, should it ring more than 12 or less than 12 if it rings every 3/4 of an hour? Well, that's because you have 9. You're not thinking about what I'm saying. In your head, now listen to what I'm telling you. You think you know the answer, so you're not listening as far as the logic behind what I'm saying. So if I said this, if I said the alarm is going to ring every 30 minutes, is it going to ring more than 12 times or less than 12 times? Right, because it's going to ring how many times an hour? If it's 30 minutes. Right, so here, no, here's what I'm asking you. Think about this. This is 1 hour. This just represents 1 hour. If I said it rings every half hour, how many times would it ring? In 1 hour. Notice, you're doing 3/4. I'm not, it's a totally new problem now. Completely new. I'm saying, what happens if it rang every half hour? How many times would it ring after 1 hour? So this would represent a half an hour. So the alarm's going to go off here. And then another half hour. It's going to go off. So let's say I started at 12. When's the alarm going to go off? At what? That's exactly right. And then it's going to go off again at what? There you go. How many times in an hour? 2. There you go. It goes twice an hour. So in 12 hours, it would go how many? Well, no, not in 1 hour. Now I'm talking about 12 hours, kiddo. It goes 2 every hour. So if I did 12 hours, well, in 2 hours, how much would it go off? That's right. 3 hours. That's right. That's right. So if I said 3 hours and you got 6, you said 2 hours, you said 4, 1 hour, it's going to be what? So what did you do from 1 to 2, 2 to 4, and 3 to 6? What operation? Multiplied it by 2. So in 12 hours, it would go off how many times? There you go. It would go 24. You with me? Now, I know you're saying, well, how does that help me? I'm trying to show you how that helps. All right? So because it goes off more than it goes off less than 1 hour, that means it's going to have to go more than 12 if it's going to be doing it every 12 hours. All right? That didn't make sense. So I'm going to try one more time. Look right here. So this is at 12. This would be at 1. This would be 2, 3, 4, 5. I'm just going to do it for 6 hours. Right? So 3/4 of an hour is 45 minutes. So it would go off at 12:45. Then it would go off at 1:30, then it would go off at 2:15, then it would go off at 3. You see what I'm saying? I'm just adding 3/4 of an hour. You agree with that? So essentially what I'm trying to explain to you is that I'm taking the number of hours and I'm dividing it, I'm cutting it up, I'm dividing it into equal sections, right? It's going to be cut up every what? 3/4 of an hour. Then the alarm's going to go off. How long is it going to be going for? For 12 hours. We're cutting it up every what? Or the alarm's going up every 45 minutes, but every what? 3/4 of an hour. You with me? So we are doing 12, not times, but we're doing 12 divided by 3/4. That's what we're doing. Just go sit over there. You, Jack. Go over there in the corner. Right now. So now, how much is that? 16. So the alarm is going to go off 16 times. That's what I'm trying to tell you. It's going to go off 16 times. Now, the other thing, I'm not going to give up right now, though. So what I'm trying to get you to visualize here is this is the total 12 hours. And I'm dividing that 12 hours into what? Into what? That's exactly what we're doing. We're taking the 12 and I'm dividing it up into 3/4 of an hour. So take 12 divided by 3/4, and there you have it, 16 times. All right? All right, so that was a little tricky. All right, no doubt about it, a little tricky. All right, now 28. All right, I want everybody to take a look at 28 for a quick second. Now, on the test, it will look like this. This fraction bar will be a little better. All right, this is called a complex fraction. This is called a complex fraction. So what does that mean? Yes, very smart. So that is the same as 3/4 divided by 8/3. All right, and what is this? No, you don't. Let's do it and see if it needed. Yes, I think it's 9/32. Now do it without parentheses and see if you get the same answer. All right. Take your calculator out and write what I said. You guys, some of you act like, what are you talking about? Type it on your calculator as 3/4 divided by 8/3. And what did you get? Yeah, that's the answer, right? Now you know how to do it. All right, I promise you, I'm telling you the right answer 100% of the time. All right? All right. All right, here we go. All right, here we go. Now, the next one, all right, is a really cool problem. All right. So, who tried 29? What'd you get? 6? 5? 6? 6? 14? 6? 4. Good. Okay. 6? Good. 16. Good. Oh, we already had it. Did you get something? What about you? All right. So here we go. Now, what I'm telling you is there's sometimes in math, all right, something comes along where you're just going to have to draw the picture out or you're going to get the wrong answer. All right? You're just going to get the wrong answer. Now, what? All right? So what I want to do is I'm going to try to show you how this problem is super easy and there's no reason for anyone to miss it. All right, but most people do what? Most people miss it. And the reason most people miss it is because it says you don't want one at the what? Start or at the end. So as soon as I saw that, I knew they were trying to trick me a little bit. All right, so what I'm going to do is I'm going to try to draw a course here. that's how long? That is what long? 21 feet long. That's what I was hoping you would say. 21 feet long. What? What? No, you're not. No, not. I'm serious mode now. Trying to get something accomplished. All right? So it's 21 feet. So everybody's going to put 21 feet. All right? Now, I don't know how you draw a cone. It's not important. All right? But we're going to draw some cones, and we're going to place them every what? We're going to place them every 3.5 feet. So here we go. So we're going to draw a cone, all right, that you know you've seen before, all right? And we're going to draw a cone, and we're going to make it every 3.5 feet, all right? So here we go. Here, right here is where the first cone goes. Does everybody agree with that? So how far from the beginning is that? How far? 3.5 feet. All right. So now I'm placing another cone. How far down the track is that?
7.
7. That is correct. Very good. Now I'm going to put another cone. And now you should look at that and say, that's what? How far?
10.5.
It's 10.5. Thank you very much, Stan. And then this is how far now?
No,
Yep, 14 feet. All right. Now the next one is what? 17.5 feet. That's perfect. And then the final cone will go
on 21.
on 21.
And then on 1. And then
Wait a minute.
off.
That's right. Hear what she said. All right. If we were just doing this, I like what you said.
I knew that was happening.
So there we did, just like that. All right. If that's normally how it's done, you put a cone at the beginning and a cone at the end. But you have to read the directions. It says we don't want a cone where? At the start of the beginning. So we're just going to backtrack. I don't need that one, and I don't need that one right there. So it is 5 cones. All you have to do is draw it out. Sienna, that's not necessary. It's totally unnecessary. Come on, we're 7th grade now.
How would you do it on my calculator?
What?
How would you figure out how?
No, I understand what you're saying. So here's what I'm saying to you. If I were to take 21 and we divided it by 3.5, everybody should be able to tell me that's what? Do that, please. 21 divided by 3.5. 6, right? So everybody put 6 down. And I'm totally fine with that. If you put that on the test, I would just know you made a little mistake. All right? The mistake was I'm taking 21 feet. Now try to listen to my explanation. I'm cutting 21 feet into what? 3.5 feet. Except I don't need what? I don't need this last mark. Subtract 1. Exactly. No, there wasn't 1 on the beginning. Because you normally start at what? 0. You with me? You don't say, if you're counting, you don't start at 0 and say that's 1. That's 1 cone. You with me on that? You would place the cone every 3.5 feet. This is not a place for the cone. You're counting every 3.5 feet. Yes. Now some of you guys who are listening, it's starting to make a little better sense. Those of you guys who are daydreaming, not with me, it's going to be confusing. What?
Well, why couldn't it just say not at the end? Why would it say not at the end?
Well, because you could place a cone there at the beginning if you wanted to. I've seen races where they start out with a cone. I'm not understanding. I drew it out for you. What more can I do? Hey, Greg, look, man, sometimes when I'm fussing, you think I'm saying I can't help you anymore, then draw out the figure and you count them. And you say, I think it's 4. You see what I'm saying, right? Look up, Greg, so I can show you something. Look, man, you're always asking me good questions. I'm not mad. I'm just showing you. Look right here at the drawing. It's perfect, right? I'm telling you, in math, you don't always just read the word problem and say that's the answer. You got to analyze it a little bit more than that. This is a problem specifically designed for people who just do what? 21 divided by 3.5 and think they're right. Because they're not reading what? They're not reading carefully. That's all. If you want to be a great math student, you got to read carefully. That's what it boils down to. And you understand, would this be a fair question, Greg? I want, especially for you. Would this be a fair question if I said, make it 700 feet? Would that be a fair question? Not exactly, because I'm going to have to draw a lot of cones if I want to cover every 3.5 feet for 700 feet, right? You see what I'm saying? So generally on standardized tests, what they do is they make the number small so it looks like that's the obvious answer. All right, so when you take these types of tests, you got to realize the obvious is a lot of times not the correct answer. And that's what I'm trying to tell you in this case right here. And there's some other tricky ones that you're going to run up to. And if you just put a little bit more thought into it, you might get a better score. That's all I'm trying to say. You with me on that? Now, did you understand what I was saying about why it's not just 4? I'm trying to say I want to make sure I answered your question, right? That's what I want to make sure I did. There's not one at the first. That's exactly correct. You with me? But I could say on the test, which is there's several types I can go with, where I could say put a cone at the beginning and a cone at the end. If I said put a cone at the beginning and the end, then there would be how many? Come on now. Whoa, whoa, whoa. Stop saying things. Yeah, now you understand what I'm saying. Stop saying things. Think before you say something, and you're more likely to get the answer correct. That's what I'm trying to show some of you guys. This number right here, the start and the end, plays a difference. Right? I could have a cone at the end. Then it would be 6. Beginning and end, it would be 7. No beginning, no end, that would be 5. Agreed? All right, is everybody happy with that? And again, I'm not some Picasso up here drawing pictures, but I also know it's very helpful, and hopefully you feel that way. All right? So here we go. Now, number 30, I'm a little upset with my last class on this one because not many people got this right either. How many? For what, though? Read the question. No. What's the... Not 4 feet. That's why I'm saying the units is important. For what? For, yes, 4 bounces. I'm not saying that's the correct answer. I'm just saying it's definitely not 4 feet. What did you put?
On the 3rd bounce.
On the 3rd bounce. 8th bounce. 3rd bounce. 9th. Okay, I'm liking it. 8th. Good. 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 What? Jack, thank you for joining now. I didn't hear you. 3rd. Good. 3rd. It's, definitely 4. All right? Definitely 4. I like that. 8. Definitely. I thought it was wow, this is something, Sean, very good. I thought it was the 3rd. You're not sure it was the 3rd? Usually you're pretty sure. Not sure. What about you? Not sure? All right, Tucker. 8, good. Okay, so here's what we got, guys. Now, I understand where some of you got the 8 from, but again, watch my drawing, all right? And I know some of you are jealous. That's part of the problem is I can draw so well and you can't. All right, so don't feel bad. All right. No, these are all my straight lines right there. Every single. I feel as if some of you don't believe me. All right. Haters. All right, here we go. All right, there we go. All right, so there's my stand. All right. Now, on my stand, I'm going to put, see, I can even draw perfect circles. All right, there's my ball. And definitely not. And how far is my ball off the ground? 6 feet. So we're going to put 6 feet. Then I knock the ball down, hits the ground. All right, and then the ball bounces back up. All right, hold up. Bounces back up. Now, everybody understands that when the ball hits the ground, it's not going to go up to the same exact height, right? All right, it's going to go 3/4 of the way up. So if it was at 6 feet, where is it going to, when it bounces and goes up, how high is it going to be now? Definitely not. How did you get 4 1/2? Everybody needs to go. It is 6 times 3/4. 6 times 3/4, and it's okay.
Yes.
It's okay, guys. It's all right to make a mistake. Listen.
Why would you multiply?
Okay, so here, that's a very good question. So listen to me again. I'm really trying to help you understand because some people are losing not the operation. So I'm going to show you how simple it is. All right. Let's say, for example, the ball was 20 feet, and I said every time it hits the ground, it comes up half its height. So if it was at 20 feet, how high is it going to come up? How did I get that? With the numbers 20 and 1/2. How did I get that? There you go. This is what I'm trying to show you. The fraction make it seem harder, but if you just make the number easier, then it's easy to figure out. So you're just multiplying the height by the fraction, and that'll tell you how high it went back up in the air.
Oh.
That's right. Exactly. So now I need everybody to take their calculator, and I want them to do 6 times 3/4, and then I want you to tell me what that is. 4 1/2. Everybody else get that? Now, come on, guys. When I say that means you're typing it on the calculator. It's just as much important to be typing it on the calculator than it is letting someone else type in the calculator and say, yeah, that's what I got too.
That's what I got.
4 1/2. All right. So now it's 4 1/2 feet. All right. So now it turns back around, hits the ground, and now it's going to come up to what height? 3 3/8. Now I'm asking somebody to confirm that. Is that right? Now on your calculator, instead of doing 4 1/2 times 3/4, everybody understand you can just hit times and it'll automatically pull up the answer. Right? So now it's 3 3/8. How many times has it hit the ground now? Once. So now it's going back up to 3 3/8, and now it's got to hit the ground again. And so on your calculator, just go times 3/4, and what number is this now? 2 17 over 32.
So it was 3.
So it was 3.
Yay.
Thank you. It was 3. All right, so I'm very happy with those you guys. Now again, I'm trying to show you something on my picture. Hit the ground once, came up, went back down, hit the ground twice, came up, hit the ground a third time, and then am I less than half? Yes, because half would be how many feet? 3 feet. Come on now. Good. Good, Tucker. Come on.
I just don't understand.
I'm going to show you one more time. Remember what I told you. Practice. And don't make a big issue over it. All right? Do not. All right? Because I can't get through if it's a big problem for you. All right? What? Right. So basically what I want to do is I want to cut 6. I want to divide that by 2. So the ball, all it has to do is come up. As soon as it's less than 3 feet, we can count the number of bounces. You agree with that? All right, so here we go, Tucker. Watch me now. Hey, you ready, Tucker? Right, so watch. I'm even, not that I'm bragging or anything, but I even like my drawing. Look, right? So my ball is being dropped. Oh. My ball is being dropped. It hits the ground, right? So how high is it going to go up?
It's going to go up 3/4 of 6.
That's, you said it perfectly. 3/4 of 6. In math, of we call multiplication. Yes. So do that on your calculator. Just a minute. Just a minute.
It's 4 1/2.
4 1/2. Now it's at 4 1/2. times 3/4. Again. There you go. And now it's less than 3 feet. It took the ball what? 3 times. Go.
Okay, so how would you know that you would? Doesn't it say the previous bound?
That's right. That means this right here. The new height is 4.5.
What was the previous?
The previous, there was nothing previous. It started at 6. And then you let it drop, and it bounced up to 4.5 feet. Because I did 6 times 3/4. So
it's just trying to trick.
no. I understand what you're saying. Let me try to show you. So it says the height of each bounce is 3/4 of the previous bounce. Well, there really wasn't a 3/4. It just started at this height. So it hit the ground. Now on this bounce, it's going to go up to what? 4.5.
Okay.
Because I can't say start a bounce on the ground.
Right.
So it has to be dropped. Is that better now?
Yeah.
Got it? All right, I'm happy with that. Ooh. Some of you have to outdo me. I see what you're doing. All right. Better picture than you. Ha ha. All right, here we go. All right, 31. All right, I feel like this one's pretty good. Tell me. 10 times 2/3. What'd you get?
6 and 2.
Now watch me. Put your hands down. Listen to me now. I need your attention here. Hold up. You listening to me? Come on, I need your eyes up. All right, everybody's eyes up. Now, here's how I used to do it. I'm telling you the honest truth when I tell you this, how I figured all this stuff out. Fractions was always hard for me. That's why I try to teach you how to draw pictures. If I said a water cooler contains 10 gallons, and if you drink a gallon each day, this is kind of what, I wish she was here. This is kind of what the problem was earlier with the time. Hold on 1 second. If I said 1 gallon a day, it would be how many? 10 days. So it's got to be more than 10 days, correct?
15.
There you go.
I
Because we're taking the whole and we're dividing it into little pieces. That's what we're doing.
What's the homework?
Hey, the homework. Listen, guys. Hey, I need you to hear me. Again, guys, I feel like today was pretty productive. Some of you guys are starting to maybe get a little better. Just continue practicing. Tomorrow I'm going to leave off right where I did. Don't go home. Yes, and you make some mistakes. Go back and correct them now. That's what I'm trying to get you to do. Bless you.